This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET. We'll see the work time graph. So what is work time graph? If I plot the work on the y-axis and time on x-axis, we get the graph as work time graph. And this graph, the slope of this work time graph gives you the value of instantaneous power, as we know that power is equal to power, or instantaneous power is equal to dw by dt. So basically, what is dw by dt? Dw by dt is the slope of wt curve. So the slope of wt curve, and it's equal to tan theta at any particular point. So suppose this is the work time graph, and if you draw a tangent at any point, suppose I draw a tangent at the point t is equal to t1, then this line gives you the value of power at t is equal to t1. Similarly, if I draw the line at t is equal to t2, the tangent at t equal to t2, then we get the value of power at t is equal to t2, and this line makes an angle theta1, and the earlier line is making an angle theta. So as we know that the slope is given by the value of tan theta, and the slope is equal to dw by dt. So p instant, or the instantaneous power at any point from the work time graph, is given by dw by dt, and the slope of wt curve, it is given by tan theta. So all these things are written here. Now we will see different types of graph and calculation of power from the graph. So suppose if the work time graph will be a straight line, making an angle theta is equal to 0 degree. So clearly, as per this figure, then the work remain constant while time passes. So clearly particle is not doing any work, and in this case power is equal to work by time t, and we may write that in fact power is dw by dt, and it's a instantaneous value. It's an instantaneous power, and dw by dt is equal to 0, as w is constant. So when wt graph is a straight line making an angle theta is equal to 0 degree, then the value of power will be equal to 0. Now we consider the second figure, when the wt graph is making an angle theta with the x-axis. So suppose this is the wt graph which is making an angle theta. So clearly, if I consider the time 0 to time t, suppose if I consider the time 0 to t, and the work done during this time will be equal to w. So clearly the average power P average is equal to work divided by time, and the average power is w by t. So from this figure, w by t is equal to tan theta, which is the slope of line. Now if we consider any particular instant, if I consider a instant this shown by the figure A, then shown by the point A, then the slope of curve at this point is also making an angle theta. So clearly in this case, if we consider any point on this curve, then the slope is making an angle theta. So in this way we may write that if the wt graph will be such that it's making a straight line with angle theta with the t-axis, then the instantaneous power and average power both will be same and is equal to tan theta. So the instantaneous power and average power in this case will be same. Now we consider the third figure when wt graph will be such that it's a making a parabolic function. So suppose this is our wt graph. So clearly if I consider a point, 4 point, consider if I consider in fact 4 points a, b, c and d. So if you see, if you draw a tangent at point a, then it is making an angle alpha 1. If I draw the tangent at point b, it's making an angle alpha 2. At c it's making an angle alpha 3, and at d it's making an angle alpha 4. So clearly alpha 1 is less than alpha 2, and it's less than alpha 3, and it's less than alpha 4. So the correspondingly tan are also increasing. So tan alpha 1 is less than tan alpha 2, less than tan alpha 3, and so on. So clearly the power is increasing. The power is the instantaneous power is the slope of wt curve, and slope of wt curve here is decreasing. So as the power is increasing, so we may infer that the force acting on the body may be increasing. So basically the force acting on the body is increasing, that's why power is also increasing. So if you get this kind of wt graph, then you just make a inference from this that power is increasing. And if you get this kind of wt curve, then you may write that the power is decreasing as the slope is decreasing. So in this case power is decreasing, while in this case power is increasing. Now we will learn power versus time graph. So a power versus time graph is given, in which on the y-axis we plot power, while on the x-axis we plot time. And here power is not constant. Suppose power is not constant, it's increasing, then the area under power time curve gives you the work done by body, as power is equal to dw by dt. So first we will learn this concept, and then we will prove this concept for a simple figure, that as power is equal to dw by dt, instantaneous power, so we get the dw is equal to p into dt. So here p is also not constant, p is also variable. So how we will calculate the work done? So in this case work done, if you integrate the both side, then it's p dot dt. Now if you consider a arbitrary time t, and then we consider a infinitesimal time dt from there. So in this case the power at this point will be pt, while power at the next point will be pt plus dt. As dt is very small, so we consider pt and pt plus dt same. So clearly power is not changing for this infinitesimal time difference. So if you multiply p into dt, it's give you a small it gives you the area of this small stripe. So the area of this small stripe gives you the will be given by pdt. Now if you integrate it, then such a small area, so if you integrate it, what it means, it means we are just adding up all such small areas. So if you add up all such small stripes, then eventually you will add the whole area. In fact you will get the whole area. So work done will be equal to area under pt curve. Now how we will put the limit for this? So for t is equal to 0, the work done will be 0, while for time t is equal to t, the work done will be w. So from there we get w is equal to integration of 0 to t p dt. So This is the basic concept that the area under PT curve gives you the value of work done. Now consider the case of constant power. Like suppose this figure, when power is constant, this is the PT graph when power is constant given by value K. Then if you have to calculate the work done during the time T1, then power is equal to W by T, and here work done, let's it equal to W, then time is equal to T1, and the power is given value equal to K. So W is equal to KT1. So basically KT1 is the area of this rectangle. So KT1 is the area of this rectangle. What it means? It means that the power is from the PT graph. If you calculate the area, you will get the work done by the body. So similarly, if a curve will be such that the PT curve will be such that, suppose this is the PT curve, which is the of the form P is equal to 3T, and you have to calculate the work done by object in time t is equal to 4 seconds. Then how we will calculate? You just calculate this area, and to calculate this area you need these two value, that 1 by 2 into base into height. So if I put t is equal to 3, t is equal to 4, we get this height of this, and it's equal to p is equal to 12. So now if you calculate, area is equal to 1 by 2 base into height, and base is 4 and height is 12. So from there we get area is equal to 24, and the work done is equal to 24 joule. Similarly, if the PT curve will be supposed in this way, then again if you have to calculate the work done during the time t is equal to t1, then you have to get this area. So suppose the PT curve will be defined in this way. This is the p axis, this is the time axis, and the curve will in this way. Then in order to get the work done for time t is equal to t1, you have to calculate this area.